sometimes this computer doesn't show up too good on this. But I'm just trying to help you with some homework. I found this in 2.2. 2.2 was kind of a minor section, but here's this problem. Determine which of these equations best fits this data. That's kind of what 2.2 was about. There were some questions about making what they call a scatter plot. And you know, I think I'll take a look at this data real quick. 0, 4, I want to plot it. 0, 4 is one piece of data. 1, 5 is another piece of data. 1, 5 is a piece of data. 2, 5 is a piece of data. 2, 5, and 3, 6. 3, 6. All right, well, anyway, there it is. Would you say that data fits a line perfectly?
No.
No. But there probably is some kind of line that sort of best fits it, or like they said, what's the better fit? What's the best fit? You know, maybe I should calculate some slopes or do something, you know. Let's look at these two lines. There's two answers here. One of them has a slope of 0.5, and the other one has a slope of 2. Both of them have a y-intercept of 4, which might be good for us. But one of them has a slope of 1/2. One of them has a slope of 2. You know, this is I'm a little bit in debate mode here. You know, back in chapter 1, I tried to just make you think about slopes, and I told you this. This line right here that makes a perfect diagonal has a slope of 1. I mean, that's what happens when you go up 1 over 1, up 1 over 1, up 1 over 1. You get this perfect diagonal slope of 1. Anything less than a slope of 1, like a half, like a slope of a half, is up 1 over 2. So it's kind of here, and a slope of 2 is higher than that, steeper than that, like a slope of up 2 over 1. So I don't know. I have this idea when I think of slopes. That's a shallow slope, that's a steeper slope. I almost still can't answer the question because I feel like the answer should be 1. I feel like the slope should be 1, almost. And they're giving me these two choices which are sort of evenly spaced around 1, I feel like. I don't know, maybe this point is kind of off, right? Maybe it's dragging it down a little. So maybe I would suggest the shallower slope is the answer. Is that what you were thinking? All right. I mean, maybe to best fit the data, I was a little off there. Maybe I need to kind of, you know, bisect this data a little better here. And then maybe I could consider that a shallower slope, and that maybe that's the better answer, which is B. But I just did this visually. I didn't do any calculations. I just kind of did it visually. Good, they think I'm right. You know, that's another one. You could plot those points yourself and just pick the scatter plot. They don't even ask about, well, they might. No, they don't even ask about. And we did this. This is easy. I mean, it's just this real funny question here. You just got to. We talked about it, but if you've never thought about it, it might be difficult. But here's some data, and except for that point right there, it looks like a line might fit this exactly. But because that one point's a little off, then your line might be just a little off, and you would be fitting this data approximately, I believe. So that's the question. Does a linear function fit this exactly or approximately? And because of that one point off, I think the answer is approximately. That's all. Pretty easy stuff. We never talked about this a lot, but that's it, I guess. That's all there is to it. Yeah. Okay, let's get out of here. What about 2-3 is where kind of the good stuff was, and I might have already helped you enough with that, but let's look at 2-3 a little bit. Do you guys have any requests in 2-3? There's a lot of good questions. I like to start toward the back. That's where the harder questions are. Yeah. Well, let's talk about this. This is one of these mixture problems. Now, on today's quiz, anyway, I'm trying to help you with some stuff. Today's quiz might not get this difficult. I don't know. I just went over these word problems Tuesday. Maybe I didn't feel like giving you a quiz today on too many. There's some stuff on today's quiz, but this is one of these mixture type problems. What I suggested was that I had these circles that kind of helped me do mixture problems. So let's see what we're doing. We got soybean meal that's 16% protein, and we got cornmeal that's 8% protein. How many pounds of each should be mixed together to get 320 pounds of a mixture that's 15% protein? Okay. So I think I remember how to set these up. I got this. And then these little circles sure helped me a lot. Let me think. I'm mixing two things together. I'm mixing the 16% stuff, which I write as a decimal, with the 8% stuff, which I write as a decimal. And I'm trying to get a final mixture that is 15%. Which, by the way, you know what that means? I already know something. I know I'm going to need a hell of a lot more of this than this. I mean, if my final mixture is close to this, I want a lot of this and a little of that. You with me? You know what? If my final mixture is right in the middle of those numbers, then I want right in the middle. If it's right in the middle, if my final mixture is right in the middle of those numbers, then I want the same amount of each, I think. But anyway, this is not, it's heavily slanted toward this one. I'm going to need a lot of that one and a little of that one to get my answer. Now, the question is how much of each? That is the question. And I don't know how much of that one, so I'll call it X. I don't know how much of that one, I'll call it Y. But I do know I want the total to be 320 pounds. They did say that. Now, from this picture, then, I can come up with two equations and two variables, kind of, and solve a system of equations like what we're practicing here in 2-3. From this picture, I say that, let me draw I'm mixing these two guys into this final batch. First off, just the amounts. Just think about the amounts. Whatever amount this is and whatever amount this is, they got to add up to 320. So that's kind of one equation. X plus Y equals 320. And then the other equation is when you do the actual mixing, you take the percent times the amount, add them together to get this final percent times this final amount. It's pretty easy. So I'm going to have a 0.16x, 0.08y, and a 0.15 times 30. It's going to equal 0.15 times 30. That's not 30, 320. That's a number, by the way. And I have myself a system of two equations, two unknowns. Hey, how would y'all solve this? We have a lot of options to solve this. Which one would you guys do? Substitution. Substitution, I would too. It's so easy to move this x over and quickly say that y equals 320 minus x. It's so easy to quickly solve for y and then take that y and substitute it in for that y. Yeah, that's what I would do. It's called substitution. Solving one equation for y, substituting it into the other equation for y. And now I have this. 0.16x plus 0.08y. Wait a minute, what's y? 320 minus x equals this number. Can somebody help me with that number? 48. 48. Thank you very much. Cool. Here we go. Let's do it. We're done. We're ready. We eliminated one of the variables by substituting. And now I can solve for x. I'll distribute this. This is 0.16x. 0.08 times that. Can you help me? 25.6 minus a 0.08x equals 48. If you subtract your x's there, you get a 0.08x, I think. And over on the other side, I'm going to subtract the 25.6. And I'll be left with 22.4.
Sounds right. No.
Subtracted 25.6. Okay, thank you. Thank you. The brain is quicker than the calculator. Cool. But now not. Now the brain is slower than the calculator. Please help me divide. 0.08 divided. X is 22.4 divided by 0.08. The brain is slower than the calculator in this case. And the answer is 280. Good. Thank you very much. 280 pounds of the X stuff. If X is 280, I can go back to the top and tell you what Y is. Y is 320 minus 280. Y is 40 pounds. And that's kind of what we predicted. We said we kind of wanted a lot of this stuff and a little of this stuff. And that's the actual answer. That's the actual amounts we want. You guys okay? So, cool little mixture word problem. Makes you write two equations, two variables, and then you solve it. I don't think it's too hard. What's the question about? Oh, the question actually wants the pounds of cornmeal. Which one was the damn cornmeal? The cornmeal was the weak stuff, right? This was the cornmeal. So that would be 40 would be the answer, I guess. Cool. And the other one, okay. The other one is the 280. Cool. Good. This is a funny question that, anyway, it won't show up on today's quiz. I don't know if you guys got to it. Did anybody do this question? All right, well, you might not be able to do it. But anyway, I'll help you next week. It's kind of funny. There's you can ask for help. You can get question help and try to understand what they're doing. I'll address that next week. This is kind of classic. This is actually another mixture problem. This was fun. Let's try this. This is good stuff here. Let's try this. But the math turns out to be not too hard. But when I start talking about these supply and demand equations, the economic theory gets a little hard to talk about. I did that a little bit the other day. And I drew this kind of just a basic picture where instead of X and Y, X was always the number of units, but now we're calling that Q for quantity. So it's still the number. It's the quantity of things you're buying and selling, or selling and making or whatever. And then and then the Y value actually is P for price, not P for profit, but P for price. And we outlined this the other day, and I think when I first outlined this, I said something wrong. There's usually a line here with a positive slope that I think is called the supply equation. And I think I had that backwards at first the other day. There's another line with a negative slope that's called the demand equation. And then we're after this place where they cross. We're after this point of intersection, which is called market equilibrium. So a lot of big fancy words, a lot of nice economic words, which is cool to learn and think about and talk about. But the math is just kind of same old math, solving two equations, two variables. I don't know, let's see what this one is. It says the supply and demand equations are this one. Let me just see if I'm right. If that's the supply equation, I'm going to write this. P equals 40Q plus 300. That does have a positive slope, right? That's the supply equation. Okay. All right. And the other one is P equals 9,300 minus 50Q. Okay, look, that has a negative slope, right, you guys? That's the demand equation. That's how they work, I guess. We can try to think more about them, but let's not. Then this is a cool question. I like this. If the price is 3,300, how many units are supplied and how many are demanded? That's a good question. So if the price is 3,300, what's supplied and what's demanded. It helps to keep these separate. One of them's supply and one of them's demand. So let's try this. If the price is $3,300, I mean, this is not part B. This is not about market equilibrium. This is a part A question, which is, if the price is $3,300, just find Q for both of them. So let's just check that out. If the price is $3,300 for that supply equation, I'm going to do, I'm going to set 3,300 in for the price. I'm going to subtract 300. That's, do a little algebra here as fast as I can. I like to do fast algebra. Divide by 40, and Q is? 75. Thank you very much. 75 units are supplied. 75 units are supplied. Okay. Let's put the 3,300 into the demand equation. If we put 3,300 into this demand equation, then I'll try to solve for this Q. It's a different Q. I'm going to subtract the 9,300. If I subtract 9,300, I get negative 6,000 equals negative 50Q. I divide by negative 50. The negative signs cancel, and Q is 120. These are the ones, this is how much is demanded. What the hell does all this mean? Well, I don't know. Let's try to think about it a second. Let's go over here to my picture. A Q of 75 is, I'm going to roughly put that here. You know, this is Q, my Q axis. So there's Q equals 75. Q equals 120 is more than that. Maybe over here. Q equals 120. And I think this price must be here. The reason I'm saying this is because I've learned to look at this picture here. So I think this price is below market equilibrium, because what's happening is I'm having a supply of 75, but I'm having a demand of 120. Now, hang on a second. That means I'm the supplier. I'm putting out 75 of these things, but the public, consumers, they demand 120 of these things. It's because the price is too damn cheap. I mean, if I raise that price, their demand would be less. I would supply more, and maybe I'd hit that market equilibrium. You with me? Right now, I'm supplying too less, and they're demanding a lot. They demand a lot. When the price is cheap, they demand a lot. So, we answered the question. When the price is 3,300, blank and blank, we get these two different numbers here. I'll type them in and see if I'm right. 75 are supplied, is that what we said? And 120 are demanded. Cool. But now to find that market equilibrium price, then I'm looking for this, then now they want the market equilibrium price. That's part B. And that, you guys should just recognize that maybe as being the point of intersection, or the solution to the system of equations. The solution to the system of equations. How would you solve this system of equations? What technique would you use to solve this system of equations?
Would you set them equal to each other?
I like the phrase, set them equal to each other. Yes, because they're both equal to P, so set them equal to each other. So let's do that right over here. We've got a little room. I'm setting this P equal to this other P, and I get to do a little bit of math here to solve this equation for Q. Let's see, I think I'll subtract the 300. That'll leave me 9,000 on that side. I'm going to add the 50Q over here. That'll be 90Q. You guys okay? Getting a little sloppy right in here. But I divide by 90, I guess Q is 100, huh?
Yep.
Q is 100. If Q is 100, plug it back into one of the original problems. Doesn't matter which original equation. But if you plug that Q in, you'll get the same price, I believe. I'll plug it right into that top equation, and I have 40 times Q plus 300. That's 4,000 plus 300. The price is 4,300. This is the market equilibrium place. If I price it like that, the supply and the demand will both be 100. If I price it right there, the supply and the demand will both be 100, and that's cool. The math's easy. The words are a little tough sometimes. You guys all right? I'm going to type this in here, 4,300, just to see if I'm right, and 100. Woohoo! That's cool. Here's another one, kind of like that. Here's one. Listen to this. I'm going to take you through just another little different story here. I'm going to use this problem and talk to you about a different little. I don't want to really do this problem, okay? I'm not exactly doing this problem, but I'm going to use this problem to do something. So. Maybe I won't use this for a minute. Hey. So, I'm in business, and what I learned is I build these things. I manufacture automobile air conditioners. Okay, cool. Automobile air conditioners. So here's what I learned. When I build 100 of these things, my cost is, okay, don't look up here. $12,955.60. Okay, that's my cost when I build 100. When I build 1,000 of these things, 1,000, my cost is. Don't look. This much, 40,000. You with me? Okay, so instead of giving you the equation, this problem gave you the cost equation. Instead of giving you the cost equation, I might like to do what I just did. So I'm not giving you the cost equation, but what I'm giving you is two important pieces of information. I'm saying when I build 100, the cost is this. When I build 1,000, the cost is this. I mean, one way to look at that, and I trained you to think like this in chapter 1, or I didn't train you, but anyway, like you're penguins in a circus. Listen, I taught you that when you look at a problem like this and think you have 2 points. You have 2 points. When I build 100, that's my cost. When I build 1,000, that's my cost. And what can you do with 2 points? You can, step 1, find the slope, and after you find the slope, you got a slope and a point, and then you can get the equation. So you can get the cost equation yourself. I know it was given to us in this problem, but I was thinking about not giving it to you, making you find it. But you can find it. You learned how to do that in chapter 1. If you got 2 points, can you find the cost equation? So let's do it. The slope is that y minus that y. These are some big old y's here, but that y minus that y, be careful, over 1,000 minus 100. You guys know how to do this, right? Can you help me? I know the denominator is 900. The numerator is? 27,990. She thinks. And then if you divide by 900, what do you get? Damn, look at that. You get 31.1 or 31.10. Since it's dollars and cents, I think this is dollars up top here. Maybe it's cool to put the 0.10 because it's dollars and cents. Yeah. Cool. We just found the slope of our cost equation. By the way, don't look up there, but we're right. Don't look up there. Okay, cool. We got the slope of the cost equation. And now that we got the slope, I think I'll use a slope and a point and do my point slope formula like we did in chapter 1. And so I'm going to do that right here. Y minus, I'm going to use this y value, equals the slope, 3110, times x minus that x value. And I'll get the cost equation. I'll distribute the 3110, and I'll multiply by 100. That's 3110. When you multiply by 100, the decimal moves over. I think I'll add this 12,955.60 to this negative 3110, and so y equals 31.10x. And when you add this with this negative number, what do we get? Really? 9,845.60. Cool. That was the equation that was given, but I was pretending I didn't know that. Just because I might do this to you. I might make you come up with the cost equation, which is kind of cool. You build it up instead of, anyway, it's nice to give it to you. But you did it. You found the cost equation. I got it called y, but that's okay. This is cost. This is my cost equation we just built. Now hang on to it. What if I told you then I'm selling these air conditioners for a price of $110.50? I sell these air conditioners, I sell these things for $110.50 each. $110.50 each. Then what's my revenue? What is my revenue? And the revenue is just when you sell one, you get $110.50. If you sell 2, you get 2 times $110.50. If you sell 100, you get 100 times. So the revenue is simply the price times how many you sell. So tell me the revenue.
$110.50. Yes, sorry.
Thank you.
Yes.
Right. My revenue is this function. It's $110.50, the price I'm selling them for, times how many I sell. I'd like you to know that. Again, they gave it to us, right? Did they tell me that? They told me that. But I'm thinking, I'm doing this because I'm adapting and rewording this question the way I might word it. Which just makes you think about this just a little bit more. But it's not too bad. Good. The book, the math app wasn't making you think like this. I'm doing this to you. But anyway, cool. Now we got a revenue and a cost equation. They gave me a revenue and a cost equation, but we built our own revenue and cost equation. I feel better about it that I built it myself. Now, what the hell's the question? When do you break even? And when do you break even? Well, I mean, just theoretically. You break even when?
Your profit equals your cost. Or
so there's 2 ways to say it, and don't get them confused. So you break even when your revenue equals your cost. But another way to say that is that your profit is 0. You broke even when your profit is zero. Maybe that's the most common thing. Maybe that's the most common sense. You broke even, your profit is not positive, your profit's not negative. You broke even, your profit is zero. But profit equaling zero means revenue equals cost. Same thing, it's synonymous. So, break even is when my revenue, look, when my revenue equals my cost. And I'm solving a very simple, I'm solving a nice, simple equation. Except I can't write. When my revenue equals my cost, I'm solving a very simple equation. I subtracting 3110, 7940. No, yes. Good, I did that right. I subtracted the 3110. This equals 9845.60. Divide by the 7940 and you got it. 124. Good, and that's, that's nice. It came out to a nice number. I don't know if mine will come out to a nice number, but anyway, cool. When I finally sell 124 units, I broke even. Before that, my business was still losing money. After that, my business will make money. But right there, I'm broke even. When I sell that many, I broke even. Well, that was fun. Let's just quit today. And